I've had a few questions about the specific heat capacity worksheet, so I'm going to take up the first two. There's a couple different things to note from each of them that you may find common throughout the whole worksheet, so I think the first two are a good example. The first one says, when 1.5 times 10 to the 3 joules of heat energy is absorbed by a beaker of water, its temperature rises by 3.1 degrees Celsius. What is the heat capacity of the beaker of water? One thing to note here is heat capacity is going to be different from specific heat capacity, and that's why mass isn't given in this question. It means the beaker is independent of mass. Essentially, you could have any size beaker and the material will absorb the same amount of energy per degree Celsius. That is also why, if you see there, that the answer here is 0.48 kilojoules per degree Celsius. No mass in the units. So it's something to watch. Let me go through this question with you. So, given in the question, we know that 1.5 times 10 to 3 joules of heat is being transferred. There is no mass, so you don't need to take that into account for this question. The C will then represent the heat capacity, not the specific heat capacity. And we're given that the temperature change is 3.1. So we're given delta T. We're not given an initial or a final temperature, just the delta T is given. This leaves us with Q equals, and there's no M, just C delta T, which is 1.5 times 10 to the 3 equals C times 3.1. Rearrange for C. And when you do that calculation, you get that it's 483.87 joules. 483.87 joules per degree Celsius. We can convert that into kilojoules and the proper significant figures, two, because both our values are given to two significant figures. So 0.48 kilojoules per degree Celsius is the answer to our first question from that worksheet. So looking at the second problem now, it says if 10.5 grams of iron at 25 degrees Celsius absorbs 128 joules of heat, what will the final temperature of the material be? So a couple things to note, the 25 degrees is not your change in temperature, that's the initial temperature. And that the specific capacity of iron can be found up at the top with all of these constants. Right here it's 0.444 joules per gram degree Celsius. So let's look at this problem. We are given in the question that 128 joules of heat is absorbed by the iron, by 10.5 grams of iron, and as I mentioned, the specific heat capacity for iron is constant. This means for every gram of iron, the required amount of energy to raise it 1 degree Celsius, 0.444. So we're solving for the change in temperature. Put up our Q equals MC delta T and plug in the values that we have. We have that 128 is 10.5 times 0.444 delta T. We can rearrange for delta T, and we would get that that is 128 divided by 10.5 times the specific heat capacity of iron. That value gives us 27.456 degrees Celsius. This is not your final answer because it asked for the final temperature of iron, given that it starts at 25 degrees Celsius, we could call that T1, and you're looking for T2. So you just add 25 to 27.456, that is 52.456, and it means your final answer is going to be 52 degrees Celsius to the proper significant